Welcome to Interface, the podcast from TasICT, presented by Steve Adermann, Chief Executive Officer of TasICT, the peak industry body for the information, communication and technology sector.
From humble beginnings, Hobart-based business ISW has grown to become an international IT company. ISW continues to grow, and its latest expansion is an artificial intelligence practice which has been headed up by former IBM AI expert Graham Walker, who joins us to talk about this exciting new project. Welcome to Interface and to Tasmania, Graham.
Thanks, Steve. My family and I love it here in Tasmania. If you have to be restricted in your travel, Tasmania is definitely one of the more beautiful locations to be restricted to. And I must say I feel very privileged to be working with such a great IT company as ISW. Yeah, they definitely have a vision on building out their business, and I look forward to the opportunity to develop and expand the AI space for them.
Artificial intelligence is a huge growth area, so let's start with the technology that underpins the project, which is Watson AI. What is that, and how does it work?
So Watson AI is the commercial result of many years of R&D work by IBM. So IBM have a very long history of working on AI projects starting way back in 1945. And over the years, they've run a number of challenges, some of which you may have heard of, such as Gary Kasparov playing chess against Deep Blue back in 1997, or when Watson was introduced back in 2011, playing Jeopardy against the human champions Brad Rutter and Ken Jennings. The most recent iteration of Watson is actually Project Debater, and this is where Watson debates human debating champions in live debates. And it's certainly worth, if you get an opportunity, to go and have a look on YouTube and just search for Project Debater. It's a very interesting viewing, seeing where AI is heading. So to answer your question, though, about Watson AI is from a commercially available point of view. Watson's somewhat of a generic term in IBM, used to represent sort of any machine learning capability, whether provided through existing products. For instance, Maximo has predictive maintenance built in, which is a machine learning model IBM have embedded into Maximo, now providing that predictive maintenance. And then there's also standalone capabilities, such as natural language processing, translation, visual recognition, and speech services, and so on, that are available in the IBM cloud.
So machine learning or artificial intelligence is effectively complex mathematics, processing data using mathematical equations. So is it fair to say the systems you're developing are just new ways of mathematic modelling?
Well, while AI certainly uses complex mathematics, there is a difference between machine learning and mathematical modeling. So machine learning uses mathematics to develop complex layered sets of computational processes that do not have a strictly defined output. So rather than what you're doing is you're giving the machine learning model a series of inputs, and for each input you tell it what the expected outcome is. This is the training data. And so in doing this, you gradually allow the model to build up the ability to predict an outcome based on a particular input. So mathematical modeling, on the other hand, it's also using complex mathematics to arrive at an outcome. But in this case, it uses predefined quantitative descriptions of how the world works to determine the outcome. So, for instance, if we take a basketball player who's shooting a ball at a hoop, to predict if the ball will make it into the hoop, a machine learning model would be trained with data such as the distance from the hoop, the direction of travel, the speed of the player, and so on, from a large quantity. So all the shots that the player has made in their career and their history. And it's tagged with the result as to whether the ball went through the hoop or not. Then for our particular game, if we're looking at a game and the player shoots on the buzzer, and we want to see whether the ball will go into the hoop or not, we basically feed in all the parameters of his motion and the ball's motion at that point into the model, and the model will use the trained model to basically provide a probability as to whether the ball is going to go into the hoop or not. We can do the same thing with mathematical modeling, but in this case what we've done is we've built up a model using real-world physics, so things like speed, direction, angles, and so on, and the physics to model whether at that point the path of the ball will go through the hoop or not. So they both provide a very similar outcome. But where machine learning really has the advantage is in situations where there is a huge number of variables that come into play, where it would be just much too complex to try creating a traditional mathematical model. For example, self-driving cars are a really good example of this. You just cannot code all the options for a self-driving car. So given enough annotated training data, meaning that we've tagged every input with the output that was achieved at that point as training data, we can train a machine learning model to be able to predict an outcome based on a set of input data.
So the more it learns, the smarter it gets.
Yes, effectively. And in fact, oftentimes what you do is you create a feedback loop so that you actually actively feed results that you're experiencing in the real world. So when the machine gives you a good result, you tell it that it was a good result. And when it gives you a bad result, you tell it that it gave you a bad result. And over time, the model gets better and better.
Well, search engines have done the heavy lifting for a long time and have been great for keywords or phrases. But is it possible to take that to another level and make machines understand concepts, context, language, and relationships between terms, say, within a document?
Yes, absolutely. That is one of the strengths of machine learning when it is used for natural language processing. So by teaching the model via annotation, what words and paragraphs mean and their context in relation to each other, we basically build up a machine learning model that can predict the meanings and context and relationship of other words and passages that it hasn't seen before. What this means is that rather than doing exact or pattern matching of words and phrases, the machine learning approach is used to understand the text as a whole and can locate words and passages based on that understanding.
In addition to understanding language, is it possible for machines to then extract data which is relevant to search, identify patterns, and say analyze results?
Yes, it is. Using the machine learning model that understands the text as a whole, you can then extract metadata from that text, and that can then be used for other purposes such as robotic processing, automation, traditional analytics, and so on.
And once that data is analysed, is a business able to then assess what a customer is likely to do?
Yeah, that's actually quite a common use case for machine learning. So while traditional mathematical models can sometimes be used to arrive at a similar result, these models require someone to explicitly define mathematically what the outcome is for each input. So when using a machine learning, we can train the model on a set of annotated data that the model then uses to learn what a likely outcome will be for any particular input.
Very good machine learning models or translation models have already been developed. Are you aiming to replace those altogether or simply building upon the existing ones?
Well, my view is that there's no sense reinventing the wheel, so to speak. There are many fantastic sort of AI capabilities that are available from large companies such as IBM, Microsoft, Amazon, Google. They're the most common big, large players, but also a lot of niche players that have developed capabilities in particular areas. So at ISW, what we do is we use existing services such as IBM Watson, that's on the cloud, to incorporate those capabilities into a solution for our customers. And if there's no existing service, or where there's a particular customer requirement that's a sort of a bespoke requirement that doesn't have a service, we would then look at building a custom model as part of the solution.
Is it difficult to determine the value of building a bespoke model at the beginning of a project?
Well, yes and no. So our customers will usually have a pretty good idea as to what value they will derive if they could perform a particular analysis of their data. So the challenge is really around whether there is sufficient data of sufficient quality to be able to develop a model for their particular outcome. So the data is key when it comes to building new models. And it really comes down to the old saying, rubbish in, rubbish out.
Now, most people in business do recognise the potential of artificial intelligence and understand they need to be active in that space, but do you find that many are still unsure of all of the benefits?
Yeah, so there's a lot of hype and a lot of media attention around artificial intelligence, and I often find that there are expectations that AI can do a lot more than what it is actually able to do today. So if I talk about the three main stages or levels of AI development, What we have is the first level, that we call narrow AI. So this refers to models that are trained to deliver outcomes in a very specific area. Many times these models are extremely capable, often better than a human, very much for their particular focus area. So for instance, AlphaGo, that was the AI that was trained to play the very complex game of Go with literally innumerable possible moves and so on, has actually beaten the human world champions. But that same AI would be unable to play chess or checkers or even, especially poker, which is a completely different type of game. So narrow AI is where most of the current capability is today. And then the next level of AI is what we call broad AI. So this refers to AI that can do multiple tasks. So at the current point of development, we're finding that this is starting to be achieved by combining a number of the narrow AI capabilities into a single solution. So an example of this actually is that same project that I mentioned earlier, IBM's Project Beta. It uses a series of very specific narrow AI capabilities that do specific tasks and assembles that into a whole that delivers that experience that you could view on YouTube of an AI debating a human. And so then the last level is general AI. So this is AI that can carry out sort of pretty much almost any task. It's able to use training from one task to extrapolate or self-train in another area. This will be the type of AI that you see Star Trek crew talking to aboard USS Enterprise, for instance. And it's very highly capable AI, but not necessarily or actually even desirable to be self-aware like we see in movies like The Terminator. But needless to say, we're still many years away from getting to the general AI point. So, that was a long introduction to your question. People have to understand that what our current AI can do and what they can't do. And once they have that understanding, they need to look inside their business for those areas that are applicable to AI.
Okay, so narrow, broad, and general. What would you class as the major benefits to business?
Yeah, so there's a wide scope of development and implementation of AI today. So it's everything from relatively quick and easy implementations using existing tools like what I sort of mentioned before that the large players have, to completely bespoke sort of blue sky attempts to solve particular problems. So my particular viewpoint is that the majority of businesses can benefit most rapidly from AI through using existing tools. So the IBM, the Microsoft, the Amazon, Google, maybe small players as well. And then using these tools to incorporate into a solution that is able to operate 24/7, doesn't need breaks, doesn't get tired of doing the same thing over and over. So one of the key areas that businesses struggle with is the ability to access all the text content that they have accumulated over the years. Very often there's a lot of valuable data in business knowledge and insight in that content. And if we can use an AI to sort of understand that content and be able to extract some metadata from that content, then we can start building solutions around accessing that information to deliver sort of business benefit.
Now, most business operators are continuously looking for smarter ways of working. Does the implementation or greater use of AI in that search necessarily have to lead to job losses?
No, not necessarily at all. Most of the businesses that I worked with are looking to augment their staff rather than replace them. This might involve things like providing their staff with the ability to find information much more quickly in order to do their job more efficiently. For instance, imagine a call center staff member who's talking to a customer. Now imagine that as they're talking to the customer, there's an AI that's listening in on the call. And as the customer is asking for information, the AI is listening to that, understanding it, recognizing it, searching for that information and displaying it in real time on a second monitor that this call center staff has. They're able to then very quickly respond to that customer without having to do searching on their own. So in this case, the AI hasn't replaced the human, but effectively made their job much easier, and they're able to resolve the queries a lot faster and that results in greater customer satisfaction and employee productivity.
It's understandable why people would be a little bit scared of something they don't know. So I'm sure that would put a lot of people's minds at ease, knowing that they're not going to be replaced by a machine.
Yeah, for sure. And I mean, we go through these sort of changes, industrial revolution with, cotton mills and so on. And, there's there are these continual changes. And I think it's part of our responsibility as a society to work out how we can implement it's no good just sitting back and saying, well, we're not going to do it because, we think the consequences, of jobs and so on is not worth it. And in fact, your competitors are going to do it. And if you don't do it, you're going to basically go out of business and all your staff will be out of work. So it's our responsibility, I think, to try and find those ways that we can best utilize. And there's tasks that humans do that we just cannot do with AI at the moment. Similarly, there's tasks that humans find extremely boring and repetitive, and potentially using machines to supplement in those spaces may provide a great result.
As you say, augment them rather than replace them.
Yes.
TasICT is consistently encouraging the government to invest more in its ICT infrastructure for the benefit of the community, the local ICT industry, and the government itself. They need to cope with large volumes of phone calls and emails. So is artificial intelligence advanced enough in this area to provide practical solutions?
This is an ideal use case for AI, actually. So, for instance, using natural language processing capabilities, such as the ones we talked about in when we were talking about search engines, we're able to build solutions that are able to read incoming emails, understand the content of that emails, and then once we've understood the content, we can extract, metadata or the specific details of that email, and then we can potentially use traditional process automation to determine what to do. So we might say that if the subject is simple and well understood, and the AI has provided a very high confidence level of its understanding, then we might decide that it's perfectly acceptable to provide an automated response, providing the requested information back to the customer. Similarly, if the subject's more complex, we might choose to route the email to the correct department or staff member. But what we might do is provide them with an email response with already details, customer-specific details, and the specific problem that the customers or information that the customer is asking for filled in. And so all that the person has to do is review it, modify it if necessary, and press send. So this can reduce the amount of time spent looking up information and writing responses from scratch quite considerably. And then lastly, if the email is very complex and the AI doesn't have a high confidence level on it, or it's just a subject area that we've determined is not to be managed or handled by the AI, then at the very least what we can do is route that email to the correct department or staff member and have them handle the matter. But that still helps by getting the email rapidly to the correct person.
Okay, I'd like to explore the practical application of your work to a specific industry which currently relies heavily on human resources, the legal profession. Now, this involves rights, obligations, precedents, and other details which can only be researched by people reading several different documents, comparing concepts, and arriving at an outcome. So does AI have the potential to handle such complex processes?
Yes, absolutely. So IBM, for instance, have developed a capability called Compare and Comply. So this tool is built on IBM's natural language processing capabilities, but it's been specifically trained to recognize, I think it's over 24 contractual clauses, and to understand the higher levels sort of concepts or legal concepts such as rights and obligations and definitions and so on. So once the AI has identified this information in contracts, you can then do things like filter the document to identify the rights of a buyer regarding payment and billing, for example. Or if you have two versions of the contract, maybe you have your original version and a version that was returned from a supplier after they had reviewed it and modified it themselves. And what you can do is you can use the AI to find both aligned and unaligned clauses. So even when the information in those clauses has been reworded from your original, or maybe relocated to another part of the document. And so this can greatly sort of assist with the analysis of these types of documents.
Okay, from law to legal tender, the banking industry has the need for reliable data and sound assessment, especially when they're dealing with types of things like risk management relating to loans or safe payments, insurance and investments. So are financial institutions and insurance companies on your radar as potential customers for this new AI business?
Yes, certainly. So the financial services industry is a great use for AI. Many of them actually have projects already underway. Now, whether those are from a customer service perspective, being able to serve customers better, or 24/7 access to information, the ability to, use AI to understand your customers better by being able to read the text of NPS type surveys, or even to the more complex areas of using machine learning models for things like loan approvals. Then there's also one of the things you mentioned there was safer payments, or safe payments. So for instance, the other area of my particular practice is AI and safer payments. And the interesting thing is that the safer payments, the processing of transactions, now involves machine learning models that are augmenting that decision as to whether some particular transaction you're doing is likely to be fraudulent or not.
An entirely different practical example, and one which is a bit closer to my heart, is the brewing of beer. How, for instance, could a brewery use AI to remove any guesswork and ensure that quality control?
Yeah, well, so in this case, it comes down to the quality of the ingredients. So the thing to remember, though, is that all machine learning models need to be built from good quality data. And that data has to contains the expected input and output, right, for your desired result. So, for instance, if a brewery has historical data that records all the various parameters of their ingredients, for water, for instance, the quantities of calcium, magnesium, potassium, sodium, etc., or maybe in their malt, the free amino, nitrogen, the protein, Colback index, etc. If they have that information for all their ingredients, and they also have some sort of measure for each set of ingredients, they have some sort of measure as to whether that resulted in a good brew or a bad brew or average brew. And generally it's humans that are making that assessment. So human experts that will taste it and sort of say, yes, this is good or not. If they have enough quantity of information in that regard, they can then use it to train a model, and it will learn the factors of all of those various parameters that we're talking about. And you can potentially be talking hundreds of parameters across all the ingredients. It will learn which parameters affect the total outcome. And given any set of input parameters, it will provide you a sort of a probability as to whether this will be a good brew or an average brew.
Well, all this talk about artificial intelligence has given me a dry throat, so I might have to go and do some quality testing of my own now. My guest has been Graham Walker, project leader for the new AI business being developed by ISW. Thank you very much for joining us on this edition of Interface, Graham.
Thank you, Steve, and you're most welcome anytime.